At precisely 10 Amenyas on April 13th, the hydrodynamic chokepoint of the Strait of Hormuz experienced a mechanical and logistical lockdown unprecedented in modern naval history. This was not a mere geopolitical declaration. It was the activation of a multi-layered, sensor-dense naval quarantine protocol. The United States Armed Forces effectively sealed off the 1-mile-wide maritime corridor, mandating comprehensive physical and electronic inspections for every commercial and military vessel, irrespective of flag or origin. The era of unchecked transit had been terminated by an overwhelming deployment of mechanized combat infrastructure. To enforce this absolute blockade, the Pentagon activated a supply chain and troop mobilization operation of staggering proportions. Currently, 50,000 heavily equipped personnel are operating at maximum readiness protocols across Middle Eastern forward operating bases, with continuous strategic airlifts preparing to scale this deployment to a staggering 100,000 troops. The airspace above the operational theater has transformed into a highly congested, precisely choreographed logistics corridor. Massive Boeing C-17 Globemaster III transport aircraft, driven by 4 Pratt & Whitney F117 PW100 turbofan engines, generating 160,000 pounds of combined thrust, are touching down with relentless frequency. They offload mechanized infantry modules and heavy munitions from their cavernous 7-foot-long cargo bays directly onto the reinforced concrete of desert airstrips. Operating at high altitudes above this logistical bridge, Boeing KC-135 Stratotankers serve as airborne refueling nodes, transferring aviation turbine fuel at 1,000 gallons per minute through their mechanical flying booms. This continuous aerial refueling architecture ensures that the tactical fighter squadrons never have to return to the tarmac, maintaining an unbroken kinetic umbrella over the maritime domain. At the absolute epicenter of this maritime interdiction matrix is the USS Abraham Lincoln carrier strike group. Displacing over 100,000 long tons, this Nimitz-class supercarrier is effectively a floating sovereign industrial complex, powered by 2 Westinghouse A-4W nuclear reactors. These reactors generate an unyielding stream of thermal energy, converted into high-pressure steam that drives 4 propulsion turbines, propelling the colossal steel monolith at speeds exceeding 30 knots. From its high-tensile steel flight deck, a relentless sortie generation rate is being maintained. Lockheed Martin F-35C Lightning II stealth platforms and Boeing A-18E F Super Hornets are catapulted into the sky using steam-powered mechanical launch systems that accelerate the 30-ton aircraft from 0 to 165 miles per hour in just 2 seconds. These airborne platforms are currently establishing an impenetrable electromagnetic and kinetic ceiling over the strait, processing gigabytes of radar telemetry to track every surface and subsurface contact within a 500-mile radius. The mechanical sequence that triggered this massive geopolitical realignment was initiated just 48 hours prior, on April 11th. The operational threshold was breached when 2 multi-billion-dollar maritime assets, the Arleigh Burke-class guided missile destroyers USS Frank E. Peterson Jr., DDG-121, and USS Michael Murphy, DDG-112, executed a high-tonnage transit through the complex bathymetry and high-current littoral zones of Hormuz. These vessels are not merely ships, they are floating supercomputers encased in high-yield steel and Kevlar armor. Built around the Aegis Combat System and the AN/SPY 1D, 3D, passive electronically scanned array radar, they represent the absolute zenith of human defensive engineering. As their 4 General Electric LM-2500 marine gas turbines roared, vibrating the very molecular structure of the hull and generating a combined 100,000 shaft horsepower, they carved through the high salinity waters of the Gulf, forcing a structural paradigm shift in the region's power dynamics. The presence of these advanced mechanical leviathans generated an immediate and severe acoustic and electromagnetic reaction from the Islamic Revolutionary Guard Corps Navy. Slicing through the background radio frequency noise of the Arabian Gulf, a harsh, unencrypted broadcast transmitted the raw friction of the encounter. The telemetry was precise, and the acoustic warning was absolute. Final warning, final warning, final warning. Divert to the Indian Ocean immediately. U.S. Navy Warship 121. This is Seppa Navy Station. You must alter course and go back to the Indian Ocean immediately. This radio transmission was the exact metric indicating that the operational tolerance of the strait had exceeded its structural limits. The tactical fault lines were fracturing, and the secondary thermal effects were already propagating across the geopolitical spectrum. Recognizing that their primary maritime axis was under overwhelming pressure, Iranian-aligned proxy forces, specifically the Houthis, initiated a parallel asymmetric escalation mechanism in the Bab el-Mandeb Strait. By targeting commercial cargo architecture with low-cost ballistic parameters, they attempted to distribute the defensive processing load of the US Navy across two distinct geostrategic bottlenecks. To manage the dual theater crisis, the Pentagon's computational models and logistics hubs are functioning at maximum bandwidth. The primary objective is to maintain the lockdown on Hormuz. The blockade operation, announced by the administration, effectively transforms the navigable channels into highly regulated toll gates, managed not by concrete infrastructure, but by phased array radars, sonar buoys, and 5-inch Mark 45 naval guns. The environmental reality of the Strait of Hormuz presents a deeply complex operational matrix. The United States Navy is not facing a symmetrical industrial adversary with comparable heavy cruisers. Instead, they must deploy their advanced systems against a highly distributed, asymmetrical naval doctrine executed within extremely shallow waters. The bathymetric profile of the strait, with an average depth of just 50 meters, severely restricts the maneuverability of deep-draft vessels, forcing the multi-billion-dollar destroyers into predictable transit lanes. This geographical constraint effectively reduces the reaction time of automated defense algorithms, such as the Phalanx close-in weapon systems, to mere fractions of a second, pushing the processing limits of modern naval warfare engineering. As the global supply chain holds its breath, the sheer density of military hardware concentrated in this narrow corridor represents one of the highest kinetic energy per square mile ratios on the planet. Beneath the surface-level observation of massive American warships lies a deeply complex, highly asymmetrical foundation of naval guerrilla warfare doctrine. The Islamic Revolutionary Guard Corps Navy operates on a fundamentally different logistical and mechanical paradigm, actively attempting to upend established modern maritime engineering rules within the constricted, shallow waters of the strait. Their primary tactical mechanism relies not on large displacement vessels, but on an ultra-light, high-speed coastal fleet estimated to number over 800 operational units. This swarm architecture heavily utilizes the Boghamar, Zulfikar, and Ashura-class speedboat platforms, engineered with lightweight composite and fiberglass hulls to minimize hydrodynamic drag. These surface crafts are powered by dual outboard commercial marine combustion engines, capable of generating enough thrust to push the vessels to extreme velocities, exceeding 50 knots. To weaponize these civilian-grade frames, structural modifications have been aggressively applied. Heavy 12.7mm, machine gun mounts, and unguided multi-barrel rocket launcher systems are directly welded onto the primary chassis, transforming rapid transit boats into highly mobile, low-radar cross-section firing platforms. The airborne component of this asymmetric matrix is equally dense. The Tehran Operational Command has engineered a spatial saturation plan designed to deploy over 300 long-range autonomous loitering munitions simultaneously. This aerial swarm is entirely comprised of the Shahed 136 Delta Wing variants and the Mahajer-class drone families. Driven by simple, loud, two-stroke piston engines, these unmanned systems do not rely on complex stealth geometries or high-thrust turbofans. Instead, they operate on a low-cost, high-volume production model, utilizing rudimentary GPS and inertial navigation systems to deliver multi-kilogram explosive payloads directly into the steel superstructure of enemy assets. Operating strictly within the Z-axis, meters below the high salinity sea surface, the operational environment has been mechanically converted into an untrackable grid of explosive ordnance. Using small, low-signature wooden and fiberglass boats, Iranian naval personnel have secretly deployed hundreds of moored and magnetic naval mines. These passive autonomous weapons drift unpredictably with the complex thermodynamic ocean currents of the Gulf. Armed with magnetic anomaly sensors, they are calibrated to detonate when they detect the massive localized distortion in the Earth's magnetic field caused by the passage of a multi-thousand-ton steel hull. In an environment where the precise acoustic mapping of these stealthy explosives is virtually impossible, They present a catastrophic structural risk to any deep-draft vessel attempting the transit. The physical constraints of this strategic waterway violently compress the reaction timelines.
The Strait of Hormuz,
at its narrowest geomorphological choke point, the Strait of Hormuz is a mere 21 miles, or approximately 35 kilometers wide. Within these extremely compressed physical dimensions, the spatial separation between the colossal, sensor-heavy US-guided missile destroyers and the ultra-fast composite speedboats is no longer calculated in vast nautical miles, but rather in hundreds of meters. It is a proximity that pushes the automated targeting processes of both sides to their absolute thermal limits. The core logic of the infamous swarm attack tactic is a mathematically driven attrition model. By simultaneously launching thousands of low-cost, low-mass kinetic targets, both on the surface and in the air. The objective is to deliberately overwhelm the multi-billion-dollar Aegis tracking algorithms and physically deplete the onboard magazines of the American defensive grid. Leaving a multi-role combat ship stranded with empty vertical launch cells in an active engagement zone constitutes the highest operational risk factor for the continuation of the US blockade. The structural or electronic disabling of even a single high-value aviation or maritime asset carries immense potential to alter the geopolitical leverage dynamics. However, the US Central Command's logistical posture indicates an absolute refusal to de-escalate. The operational parameters dictate a continuous blockade to paralyze the Iranian port infrastructure, fully aware that a tactical retreat in the Hormuz theater would establish a dangerous precedent, potentially replicated by peer competitors like China in the Pacific Rim or Russia along the Eastern European logistical nodes. Recognizing the vulnerability of standard maritime formations, the Iranian command is systematically maximizing its land-to-sea kinetic capabilities. The rugged, highly elevated, and geologically complex Iranian coastline overlooking the strait serves as a natural fortress. Hidden deep within these limestone cave networks and reinforced concrete bunkers are hundreds of mobile anti-ship missile transporter, erector launchers, TELs, and subterranean drone manufacturing and launch facilities, insulated from standard orbital optical reconnaissance. The ballistic and cruise missile inventory stationed here includes the Noor and Qadr systems, alongside the highly dangerous Khalij Fars, a solid propellant anti-ship ballistic missile capable of achieving supersonic terminal velocities, subjecting defensive interceptors to extreme aerodynamic and computational stress. To neutralize this heavily fortified coastal infrastructure, the US military, arguably the planet's most resource-dense and technologically sophisticated mechanized force, has initiated specific counter-battery protocols. The immediate tactical solution to the high-speed boat swarm does not rely on multi-million-dollar interceptor missiles, but on overwhelming kinetic volume. Enter the Fairchild Republic, A-10 Thunderbolt II. Historically engineered as a highly durable close-air support platform for suppressing heavily armored ground units, the integration of the A-10 into this maritime choke point is a precise engineering countermeasure. The core of this twin-turbofan aircraft is the legendary 30mm GAU-8 A Avenger, a hydraulic-driven 7-barrel Gatling-style autocannon, capable of firing heavy depleted uranium armor-piercing incendiary rounds at a staggering cyclic rate of up to 3,900 rounds per minute. The Avenger cannon generates enough raw kinetic energy to instantly shred the fiberglass structural integrity and engine blocks of the agile attack boats. Following recent logistical shifts, the deployment of A-10s at Middle Eastern bases has doubled, reaching a total airframe count of approximately 30. These rugged aviation assets are currently conducting continuous low-altitude combat air patrols directly above the strait, systematically restricting the operational radius of the Iranian surface elements through the constant threat of high-density ballistic suppression. While the A-10 Thunderbolt platforms provide critical low-altitude kinetic suppression, the true existential threat to the blockade, the massive, deep-strike anti-ship missile batteries, remains heavily shielded within the Zagros Mountain coastal topography. To neutralize these subterranean launch nodes, the Pentagon requires a radical escalation in raw explosive yield and structural penetration capabilities. The operational environment shifts from low-altitude autocannons to high-altitude, high-payload strategic bombing networks. The airspace is currently being saturated by the massive radar cross-sections of the United States Air Force's heavy bomber fleet. The Boeing B-52H Stratofortress, a colossal subsonic platform powered by 8 Pratt & Whitney TF-33 turbofans, and the Rockwell B-1B Lancer, a variable sweep-wing supersonic heavy bomber utilizing 4 General Electric F-101 afterburning engines, have been forward deployed. Launching from strategic hubs like RAF Fairford in the United Kingdom, these aviation giants execute transcontinental logistics routes to maintain station over the operational theater. Their primary operational directive is the structural annihilation of the Iranian underground launch infrastructure. These bombers are not equipped with standard fragmentation ordnance. They carry heavily reinforced, precision-guided bunker-buster munitions, such as the GBU-28 or the massive 30,000-pound GBU-57A. B. Massive Ordnance Penetrator, MOP. Engineered with high-strength steel casings and delayed-action fuses, these weapons are specifically designed to survive the extreme kinetic stress of penetrating deep into solid bedrock and meters of reinforced concrete before initiating their massive high-explosive payloads. A single, precisely calculated bombing sortie possesses the thermal and kinetic capacity to instantly collapse the subterranean tunnels and launch silos that Iranian engineering units have spent decades excavating and reinforcing. The US Central Command's tactical logic is a masterclass in preemptive mechanical disruption. Instead of attempting the computationally intensive task of intercepting a Mach 3 sea-skimming cruise missile mid-flight, the strategy is to systematically dismantle the entire kill chain at its source. By vaporizing the hardened missile tails, destroying the deeply buried command and control server farms, and permanently blinding the coastal early warning phased array radar networks, the US Air Force aims to fully dismantle the launch architecture before a single solid propellant engine can ignite. This high-yield air campaign is designed to functionally neutralize Tehran's primary geopolitical lever, the threat of turning the strait into an inferno of anti-ship ballistics. The Iranian military command operates under the grim realization that initiating their first anti-ship missile launch protocol is effectively a suicide trigger. Any aggressive radar lock or thermal bloom from a launch site will immediately draw the overwhelming electronic warfare suppression and structural destruction capabilities of stealth F-35S and heavy bombers directly onto their coordinates. Attempting to contest an airspace dominated by advanced fifth-generation sensor fusion and electronic attack architectures represents an almost insurmountable technical barrier for Iran's older generation surface-to-air missile systems. Despite the absolute US air dominance, the complex maritime environment of Hormuz still harbors extreme risks. The unpredictable acoustic propagation within the shallow, highly saline water column makes detecting low-signature threats incredibly difficult. To counter the insidious, drifting magnetic naval mine network, the US Navy deploys advanced autonomous systems, utilizing artificial intelligence-equipped, uncrewed underwater vehicles, UUVs like the knifefish. These torpedo-shaped drones execute continuous, high-resolution acoustic sweeps of the seabed. Operating silently meters below the surface, they process complex sonar algorithms to differentiate between natural seabed clutter and precisely engineered explosive casings, fighting a relentless, automated war against Iran's primitive yet statistically dangerous mine deployment tactics. If the multi-domain clearance operations involving autonomous submersibles, close air support jets, and Aegis destroyers fail to rapidly unlock the strait, the extended continuation of this physical blockade will trigger catastrophic shifts in global macroeconomic logistics. The United States' primary operational objective is the re-establishment of a sanitized, secure transit corridor for high-tonnage energy shipments, fully insulated from Iranian asymmetric harassment. The immediate consequence of the US blockade declaration was a massive, visible rerouting of the global energy supply chain. Satellite telemetry monitoring the Maritime Automatic Identification System (AIS) data revealed a dramatic restructuring of naval traffic. Ultra-large crude carriers (ULCCs) and very large crude carriers (VLCCs), such as the Mombasa B and Agios Fanurios, colossal floating storage tanks, displacing over 300,000 deadweight tons and carrying millions of barrels of crude oil, executed emergency navigational maneuvers, drastically altering course to avoid the high-density kinetic engagement zones, seeking refuge in the deeper, safer anchorages of the Gulf of Oman. The geopolitical ramifications of this logistical freeze were starkly outlined by presidential statements regarding the destination of these rerouted energy megastructures. While the American naval blockade effectively severed the primary hydrocarbon export arteries of the Middle East, massive empty tanker fleets holding position in international waters were being forced to adjust their logistics chains toward the high-capacity refining infrastructure and export terminals along the U.S. Gulf Coast, specifically in Texas and Louisiana. This absolute interdiction of maritime trade routes has pushed the Tehran regime to the brink of total economic asphyxiation. The immediate cessation of daily crude oil exports, historically oscillating between 2 to 3 million barrels per day, completely severs the financial input necessary to maintain the structural integrity of their heavily subsidized war economy. However, beneath the surface of the US-Iran military friction lies a much larger structural fault line involving global industrial capacity. The entity suffering the most significant logistical disruption from this naval blockade is not the embargoed Iranian state, but the massive, energy-hungry industrial complex of the People's Republic of China. Operating as the primary manufacturing node of the global economy, China requires an immense, uninterrupted daily influx of approximately 11.6 million barrels of crude oil to fuel its sprawling factories, chemical plants, and transportation networks. Nearly 20% of this critical energy requirement is sourced directly from Iranian wells, specifically utilizing complex, shadow fleet logistics to bypass standard American financial sanctions. The crucial metric escalating this geopolitical crisis is the financial architecture supporting this massive oil flow. The Beijing administration facilitates this high-volume energy procurement entirely outside the SWIFT financial messaging network, utilizing direct currency swaps in yuan or untraceable cryptographic assets. This represents a deliberate, structural challenge to the global hegemony of the US dollar. By establishing specific transit toll mechanisms through the Iranian parliament, prioritizing Chinese maritime logistics and processing payments in non-dollar denominations, an alternative, sanctions-resistant energy corridor was being solidified. The April 13th US naval blockade must be viewed through the lens of macroeconomic strategy. It is a calculated kinetic operation designed to systematically dismantle this emerging dollarless energy supply chain. When the executive order mandated the physical interdiction of any vessel non-compliant with the US quarantine, it effectively weaponized the world's most critical geographical chokepoint against the primary input of the Chinese industrial machine. With nearly 50% of China's total crude oil imports geographically mandated to transit the Strait of Hormuz, the lock to their economic engine is now firmly controlled by the automated turrets and phased array radars of the US Navy. If this blockade holds, cutting off the flow of heavily discounted, non-dollar Iranian crude, the logistics algorithms of the Chinese state-owned energy corporations will be forced to undergo a massive, highly expensive recalibration. They will inevitably have to reroute their very large crude carriers to alternative, higher-cost global suppliers, including the United States itself. Crucially, this logistical pivot would force Beijing to reintegrate these massive energy transactions back into the US-dominated global banking architecture, completely collapsing years of systematic de-dollarization efforts across the Asian and African continents. The ultimate test of structural integrity for global peace hinges on a single, high-stakes maritime scenario. If a massive, 300-meter-long Chinese-flagged oil tanker is ordered by Beijing to maintain its current bearing and physically challenge the US naval perimeter. In that precise moment, the complex Aegis combat algorithms will hand operational control over to human decision-makers. Will the US Navy initiate physical boarding procedures or fire warning shots from their 5-inch deck guns to halt a sovereign merchant vessel in international waters? If kinetic force is applied, Beijing may categorize the action as a direct violation of territorial sovereignty, providing a casus belli for massive geopolitical retaliation, potentially accelerating the timeline for operations in the Taiwan Strait. Conversely, if the US naval perimeter yields to Chinese logistics, the entire strategic architecture of the blockade dissolves, fundamentally shifting the balance of power in the Gulf towards alternative financial and military centers. The automated targeting systems are locked, the logistical pipelines are frozen, and the next move on this multi-trillion-dollar industrial chessboard will irreversibly redraw the operational parameters of the global economy for the next